Hi everyone. So let me discuss some of the properties based on group and abelian group. Okay. So theorem prove that cancellation laws holds in a group. Okay. So proof for this is if G is a group for all a comma x comma y belongs to G, then we can write x is equal to ay. So using left cancellation law, we can write this as x is equal to y. Xa is equal to ya. So using right cancellation law, I can write x is equal to y. X is equal to y. So first we say this ax is equal to ay, that implies that x is equal to y. So given ax is equal to ay, so A inverse be the inverse of A in G. A inverse be the inverse of A in G. So then I write ax is equal to ay. So later I multiply A inverse on both sides. Then right side of this equation we multiply A inverse. Then it will become A inverse into ax is equal to A inverse into ay. Okay. So later using associative law, I can write this as this equation as by associative law. Associative law, it will become A inverse into A is equal to A inverse into A into x is equal to A into A inverse into y. Okay. So it will become by using inverse law. Inverse law, A into A inverse becomes what? Ex is equal to Ey. So using identity law, Ex can be written as identity law. Ex can be written as what? X is equal to y. X is equal to y. So next is xa is equal to y. Given that xa is equal to y, so let A inverse be the inverse of A in G. Okay. So then xa is equal to y. So I multiply left side of right side of xa by A inverse. So then xa A inverse is equal to ya A inverse. So multiplying A inverse on the left side, not left side, right side. Right side. Okay. So then using associative law, so I can write this as x into A inverse. Associative law. So using inverse law, I can write A into inverse as E. So using identity law, I can write x into E is equal to x. So therefore, the cancellation law holds in group. So either we have proved right side also and left side also. So in both the cases, our cancellation law holds good. Therefore, cancellation law hold in a group. So next result is some of the theorems on abelian group show that every group G with identity E such that A square is equal to E for all A belongs to G is abelian. So here proof for this is let A comma B belongs to G, then by given condition A square is equal to E and B square is equal to E. So I write here A into A is equal to E. A into E, this can be written as A into E. A into A is equal to E. So later I multiply A inverse on both sides, then it will become A inverse into A is equal to A inverse into E. So using inverse law, we can write A inverse into A is equal to E. E into A is equal to, so A inverse into E is equal to A inverse using identity law. Okay. So then it will become A into A inverse. A into A inverse. So similarly, we can get the result of B is equal to B inverse. B is equal to B inverse. So as G is a group, so that A comma B belongs to G, that implies that product of these two also belongs to G. So now I take AB square is equal to E. AB square is equal to E because A square is equal to E. So then product of that is also E. So this can be written as AB into AB is equal to E. So and this can be written, I am multiplying AB inverse on the right side. Okay. So then AB into AB into AB inverse is equal to E into AB inverse. So AB into AB inverse is equal to what? E. So multiplying this becomes AB inverse. So AB into E is equal to AB inverse. So this implies that AB into E is equal to AB. This is equal to, this is, we have already proved this result as AB inverse is equal to B inverse A inverse. So then AB becomes what? BA. So this shows that Z is a abelian group. Z is a abelian group. Okay. So next result is prove that Z is a abelian group if B inverse A inverse into BA is equal to E for all A comma B belongs to Z. So we have B inverse A inverse into BA is equal to E. Okay. So this can be written as using so here I am multiplying B on right side, left side. So B into B inverse A inverse into BA is equal to B. Okay. So B into B inverse is equal to what? E. E into A inverse into B into A is equal to B. So using multiplying this, it will become A inverse B into A is equal to B. So I am multiplying now left side by A. So A into A inverse into BA is equal to AB. So it will become E. A into A inverse is equal to E. B into A is equal to AB. So E into BA is equal to BA. This is equal to what? AB. Therefore Z is abelian. So next result is show that if x comma y are any two elements of a group Z, then xy square is equal to x square y square if and only if Z is abelian. So once we have to take Z is abelian group and we have to prove this result, and once we have to prove using this result Z is abelian. Okay. So given that Z is abelian, so we have to prove that xy square is equal to x square y square. Now I take xy square is equal to xy into xy. So this can be written as using associative law x into yx is equal to y. So but xy is equal to yx, therefore I write here x into xy is equal to y. So using associative law again I write x into x is equal to y into y. So therefore xy square is equal to x square y square. So conversely, given that xy square is equal to x square y square, then we have to prove that Z is abelian. So xy square is equal to x square y square. So this can be written as xy into xy is equal to, this is written as xx, this is written as yy. So using associative law, I can write this as x into yx is into y is equal to x into xy into y. Okay. So using left cancellation law, we can write this as yx into y is equal to xy into y. So using right cancellation law, we can write this as yx is equal to xy. Therefore Z is abelian. So next, if Z is abelian group and for all x comma y belongs to Z, then prove that xy to the power n is equal to x to the power n, y to the power n. So we prove this result by mathematical induction. So first I take if n is equal to 1 in this equation, is the result is holds good or not. So xy to the power n 1 is can be written as xy. So this is equal to x to the power 1 into y to the power n. Therefore the result is true for n is equal to 1. Yes. Let us assume that the result is true for n is equal to m. Then xy to the power m is equal to x to the power m into y to the power m. Now we prove that the result is true for n is equal to m plus 1. Therefore xy to the power m plus 1 is equal to, I can split this as xy to the power m into xy. So this can be written as x to the power m into y to the power m into xy. So using associative law, I can write this as x to the power m into y to the power m into x into y. So since Z is abelian, this can be written as x into y to the power m. So therefore x to the power m into x into y to the power m into y using associative law. So therefore xy to the power m plus 1 is equal to x to the power m plus 1 into y to the power m plus 1. If I multiply these two, then you will get x to the power m plus 1 into y to the power m plus 1. Thus the result is true for n is equal to m plus 1. Hence by mathematical induction, the result is true for all the value of n. True for all the values of n. So with this I conclude this class. If you have any doubts regarding this, you can send questions to my WhatsApp number and clarify your doubts. With this, thank you one and all.